All right, we have a new section, 11.1, which is solving linear systems. A linear system, right, is a system of linear equations. That just means it consists of two or more linear equations that have the same variables, x and y in this case. A solution of the system of linear equations with two variables is any ordered pair that satisfied all equations in the system. So we're going to talk about just graphs of that really quick, right? So we have this graph and we see two lines, right? Describe the relationship between the two lines in this. Well, we can see that they touch once. They touch one time or share one solution, right? Because that ordered pair right there, whatever x and y is right there, is a solution of both equations. What do you know about every point on the graph of a linear equation? Every point is a solution for that singular equation, right? This point's a solution to this line, this point's a solution to this line, and so on. And then we get up here, and that's a solution to both lines, right? How many solutions does a system of equations have if the graphs of the two equations intercept in one point? One. Right there. That point right there. All right? We got a new one right here. Describe the relationship between the two lines that coincide. What they're saying is two lines lie on top of each other. You always see one, but it's really both of them that are exactly the same line, right? Describe the relationship. They are the same line, right? There's two right there, right? How many solutions does a system of two equations have if the graph of the two equations intersect at infinitely many points? Well, infinite solutions. Alright, let's keep going. There's a page. There's a lot of pages in this one. Describe the relationship you see for these two lines. Well, these two lines are, they are parallel. Right? They lie next to each other. How many solutions? No solutions, right? They never ever touch each other. Explain why the solution of the system of two equations is represented by any point where the two graphs intersect. Well, the one point lies on both lines, so is a solution for both. I'm gonna keep going. Hasn't been too long. Let's keep trucking along. All right. So there's a couple here. Solving consistent, independent linear systems by graphing. All right. A consistent system is a system with at least one solution. That's it. Consistent systems can be either independent or dependent. There we go. So we know that this has at least one solution, and now there's two more. An independent system has exactly one solution. A dependent system has infinitely many solutions. So you can be consistent and independent if you have one solution. You can be consistent and independent with a lot of solutions. All right. The graph of a dependent A system has no solutions is inconsistent. So when something doesn't have solutions, right, then it's inconsistent. So we can see this one's done for us. We're going to skip ahead and we are going to graph another one right here. All right. So we have two lines and we're going to graph them with intercepts. All right. My x-intercept is when y is 0. So if I make y 0 and add 2 to both sides, I get 2 equals 2x. If I divide by 2, I get x equals 1, x-intercept of 1. And my y-intercept is when x is 0, so if I do that, I can see that it's negative 2. Now what's a third point? We can do this in our head, right? If I plug in 3, 3 times 2 is 6, minus 2 is 4, 3, 4. Alright. This one's in standard form, so it's a little easier to get the intercepts. My x-intercept right there, through 6 times 3 is 18. My y-intercept right there, right? We got, what, 3 times 6. Now if I plug in 1, alright, so 3y plus 6 times 1 equals 18. Subtract 6, 3y equals 12. And y is going to equal 4. So let's do it. X-intercept of 1 for this guy. Y-intercept of negative 2. Looks like that's a pretty good drawing. This one has an x-intercept of 3, a y-intercept of 6. Looks like that's a pretty good drawing. It looks like they cross right there. Lines appear to intersect at 2, 2. So if we plug it in, let's check it out. 2 equals 2 times 2 minus 2. 2 equals 4 minus 2 is 2. It works for that one, right? If I plug in 2 for x and y here, 2 plus 2 times 2 is 6. Yeah, the point satisfies both equations, so the solution is 2, 2. Alright. How do you know the system of equations are consistent? And how do you know they are independent? Well, they're consistent because they have at least one solution, and they are independent because they have one solution. Alright, I think there are, alright, I think there's 2 more. Let's do it. Alright. So, if I graph this guy, this is a slope intercept, so I'm just going to go ahead and graph a slope intercept, right? This intersects at negative 2, so I put a point at negative 2, and it's got a slope of negative 2. So down 2 over 1, down 2 over 1, and I'm going to graph, oh, I missed a point right there, but it looks kind of like that. Alright, this one, the x-intercept, if I cover that up, is 2. The y-intercept, if I cover that up, is 1. And they graph like that. So my solution should be right there at negative 2, 1. Let's plug it into this guy right here. So 1 is equal to, oh, that's not negative 2, 1, is it? That's negative 2, 2. I read that wrong. So we'll go 2 is equal to negative 2 times 2 minus 2. 2 is equal to, oh, that's negative 2. 4 minus 2, so that one works. We'll do it here. If I plug in 2 plus 2 times negative 2 equals 2. Oh, that's negative 2 again. I'm plugging in the wrong x value. Negative 2. And the y value is 2. Oops. Plus 4 equals 2. 2 equals 2. That is correct. It works. So we've solved this. It is consistent and independent. Let's do one more. Alright, this guy crosses at 8 right there. It's got a slope of 2. Well, I can't go up 2 to the right one, so I'm going to go down 2 to the left, 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 and just go ahead and do my best to cross that. This one with intercepts, if I cover my y, my x-intercept's negative 6. If I cover my x, my y-intercept is 6. And it looks like the solution's right there. So my solution is negative 2, 4. If I plug it in here, 4 equals 2 times negative 2 plus 8. That is true. If I plug it in here, 2 equals, 2 plus 4 equals 6, and that works too. Alright, we have one solution. And I think we're going to stop with that, and we have a new section coming in. Alright, so I'll get right back to you, post this guy,